Want to learn how to solder like this? Stick around and I'll show you how. Hey, it's Straw Hat Sam here. So I've gotten lots of questions about my soldering joints and how I can get them nice and shiny, even on those difficult joints like on the battery terminals of your ESCs. So this video is a guide on how I do my soldering. I'm sure there's a good handful of other proper techniques that will get you a good, reliable, clean joint. But this isn't a troubleshooting guide. This is more just me showing how I do things in order to have really secure, reliable, and shiny solder joints, but not damaging your electronics at the same time. So there will be a demonstration of me actually doing a difficult solder joint. But first, let's cover some things that I keep in mind when I'm doing soldering. One is the tip size. Size does matter when it comes to soldering tips. It's not as much as you think about the wattage of your soldering iron. I use a Hacko, which is 65 or 70 watts, but I'm able to do X-class size electronics with this, small soldering iron. The reason why is because I'm using fatter chisel tips, and I believe the reason why that works is because it acts as a heat reservoir, and also it increases the surface area of the contact with the solder joint, and that increases the heat transfer to the joint and melts all the solder. Secondly, super important, a fundamental principle that I follow with soldering is I always tin both of the surfaces. So if you imagine two wires being joined together, you should tin this wire, and then get a blob of solder to fuse them together. This ensures that both surfaces have good contact with the soldering alloy. Also, you want to minimize your contact time with the solder joint. The reason why is because in my experience, when I've had issues with ESCs, like them rebooting or ESCs dying or something like that, I can recall that it was times when I was really struggling with that solder joint and I was applying heat, but for an extended period of time. Like I was leaving the tip on the electrical component for too long, and I noticed things were not, there was some weird stuff going on. So I've noticed now that I've gotten better at soldering that I seem to have less issues with my electronics. And I think that comes down to how much time your tip is spending on the joint, making that as short as possible, because heat transfer it depends on the conductivity of the, in this case, the metals involved, but also it has to do with time. So if you can shorten that time and only dump enough energy to be able to melt the solder and bind to the two surfaces, but shorten the time enough to where that heat doesn't spread beyond the joint and start to damage the dielectric on the electrical component, then that's where you want to be. Number 4 is a big one, using some kind of external flux. Flux is the liquid or powder. Most people use rosin core solder, and it's this powder that is on the inside of the solder. So that's why when you apply it to your iron, you see this smoke coming up. That's the rosin that's, it's burning or doing something. But what it does is it helps the joint, it helps the solder flow, and it activates the surfaces. It chemically deoxidizes the metals so that they're more receptive to having the solder flow into the pores of the parent material. This external flux can come in the form of like a liquid or paste or using a solder pen. For a while I was using a paste, but I've actually gone to using a liquid, and I'll talk more about that. Choose the correct order in which you solder your components. This matters because things can be made a lot easier if you just plan ahead. If you plan out the lengths of your wires first and solder the little components first and then bring them together, it can make things a lot easier so that your fingers don't have to navigate all the standoffs and things as much as you have to. I kind of left out a big factor in soldering, and that's your temperature. Of course, you're gonna want to use different temperatures for each type of solder joint. Generally, for flight controller contacts, you can reduce it to 350 degrees Celsius and use a fine tip pencil style soldering tip. And then for bigger joints like the battery pad terminals on your PDB or your 4-in-1 ESC, you want to use a bigger chisel tip and then set your temperature high to 450 degrees Celsius. This doesn't mean that you can leave the soldering tip on there for a long time, though. That means you have to work quickly. And then on your individual ESCs, once again, these can be like absolute heat sinks. So again, 450 with a big fat chisel tip, especially for these APD ESCs. You want to work quickly, so you want to be able to dump heat as quickly as possible, and that requires a large tip and a high temperature. For that middle zone, when you're soldering your motor wires to your 4-in-1 ESC, for example, maybe 400 degrees Celsius, and then a slightly smaller chisel tip would be good for that. But I know some of these 4-in-1 ESCs can be quite heavy duty, like the Holybro Teco 65 amp one. That one, sometimes I do have to bump it up to 450 just to solder the motor wires. But high temps, you just got to be careful. You got to work quickly. And then lastly, clean the joint thoroughly. So some people, they leave the flux on there, which is fine. There are called no clean fluxes where you can leave the residue on there, and it's an insulator, so it's not going to cause a short or anything, and you can get good reliable solder joints that way. But if that's the case, you want to make sure that all solder balls, which can fly off during the soldering process, make sure all of those are clear of any contacts on the board. Now, what I do for all of my joints, I like to conformal coat. I used to live in the Pacific Northwest, but I know that my drones will be used all over the world in all sorts of crazy circumstances. So conformal coating is something that I always do. In order to conformal coat, it adds an extra step to your process because you have to make sure that your board is completely clean, that there's no residue or greases left on the surfaces, because that will prevent the conformal coating from 1, wetting the surface properly, and 2, infiltrating all of the contacts so that it can protect the board from short circuits due to moisture. Okay, so now let's get to soldering. Here are the tools of the trade. I use 6337 solder, both a thin and a thick version. Thin for precision flight controller stuff, thick for battery terminals and stuff. I use solid core. And the reason why is I prefer to use solely a external flux. With the rosin flux that's embedded into most solders, it's solid, it's a powder form. So when you apply it and it melts all over the surface, it's hard to clean off. It forms this brown crust. Now this stuff here is basically the same thing, but it's in liquid form and it's dissolved within isopropyl alcohol. And eBay sellers, resellers, they bottle Kester 186 into these little applicators, which are quite handy. And for cleaning, I use isopropyl alcohol in a spray bottle with a toothbrush. Using something in a liquid form like this, as opposed to like a paste and a toothpick, because the solid content is so low, it's enough to make the solder flow. But when cleaning it with isopropyl alcohol, it comes off much easier. There's much less of a brown crust. You don't have to pick it off with a tiny screwdriver or something. All you have to do is just brush it away with isopropyl alcohol. So that puts less strain on the components, less liable to damage things, and it makes a cleaner surface for adhesion of your conformal coating if you do such a thing. Okay, let's get started. I'm warming up the soldering iron to 350C, and we're going to prepare this 9-volt regulator. What we're going to do is work from the outside in, because remember when I said about choosing which components to solder in order? This is what I'm talking about. I prefer to do the small peripherals like this first, before soldering them to the main battery terminals of the ESCs. and that saves you from having to fiddle around, because this is much easier to work with when it's free like this. And then the tip I'm using is a pencil tip like this. Okay, and forgot to mention, like, I use a solder sponge mostly just for cleaning, and I made this 3D printed tray so I can just use a regular dish sponge. Okay, first we gotta apply some solder to the soldering iron. So I just put some flux on the solder, and this is because I'm using solid core solder. If you're using rosin core, you don't need to do that. So it's an extra step that I have to take, but it saves me time in the long run because the cleanup of the joints is a lot easier. So let's prepare the things that we're going to attach to this regulator. I always put a little capacitor on all my regulators, and this prevents DJI freezes, even on 8S builds. So to do that, I'm going to stick this thing in here, how it's going to go. Oop, wrong way. And give it a little bend. Okay, and then I'm gonna snip it off at the correct length. Just to brace it. These helping hands are really great because they have this knurled nut that locks the alligator clip at the right position. So I unscrew it, twist it around, and then screw it back. So I really like these helping hands. So I'm gonna break my first rule. Instead of pre-tinning both surfaces, I'm going to solder directly. Why is that, Sam? You're breaking your own rules. The reason why is so I can position the capacitor. It's a lot easier this way. This is something I only do for this process here. Okay, so the positive was easy. Let's see if the ground goes as well. Okay, that's all right. So with the ground on these regulators, it really soaks up the heat quite quickly, and so to combat that, you can raise the temperature of the soldering iron in order to ensure that you get proper flow. So that looks better. Just to make sure, let's go on the back side of this regulator, and little dab of flux. That was a little too much. And let's get that flowing. See, this is what happens if I don't put flux on my solder like this. It makes this awful stringy mess. So for me, since I'm hardcore, I have to do it this way. So that's a lot better. Okay, and yeah, I'm just gonna give that a dab. Attack it from both sides. Okay, and the reason why I'm making it secured on this side as well is because I'm going to be soldering my input wires to here. Okay, so I'm going to bring my temperature back down because I only have it at 350 for pre-tinning my wires. So this is, what is this, 22 gauge. So I'm going to use the 22 gauge thing on my T-strippers here. And I want a little more off there. There we go. Okay. Apply some flux to the wires. And then, for me, extra step, because I gotta do that mumbo jumbo, and get a little bit of flux on my tip. And this is nice because everything is free. All I have to do is apply it and then twist it, and it gives you a beautiful, nice coat of solder there. So I don't think I have to reapply any more to my tip. I think I have enough. And normally I have a fan going. I have a fan. She's my biggest fan, this one. And it's just like a regular $15 fan from Target or Target. And that clears out the flux fumes. But for this video, I have it turned off so that you can hear me. Okay, next is the output for this regulator. I'm going to do the same process. Strip these. Having a tool like this will save you a lot of time. It makes wire stripping so much easier. You should invest in something like that. So I'm applying a little bit of flux there. And let's see if I have any more. Oh, I have to put more solder on my tip. Okay. And if you're in a position where you can't twist the wires for whatever reason, it's just as good if you like hit it from the top, hit it from the bottom, hit it from the side, hit it from the other side. It's kind of pointless with a wire this small, but for motor wires, that's a neat trick. Okay, now let's tin the remaining contacts on the regulator. Oh, before doing that, let me make sure there's some flux. Okay, and what are we at? We're at 350. And I always have a little bit of solder on the tip before I touch the pad, because without any solder, you're not going to be able to heat up that pad. You need a little bit of solder to conform to the contact so that heat transfer can happen. So notice on the other side, with these through holes, they're called like junctions. I like to solder both sides to be thorough. Okay. All right, both sides are prepped and ready to go. Not quite yet, actually, because I like to apply some flux before the fusion process. Fusion meaning the joining of the two things. So that means flux back on these pre-tinned wires. And I'm going to do these thicker ones secondly. I'm going to do the DJI power first. And that's because I'm going to start from the further side and work my way inward. That will make things easier to access, I guess. So let me just clean off with my sponge. Gotta apply some more flux to my solder. Okay. I don't like the way that went on. There we go. And with these through holes, I try to get the wire into the hole. Just like that. It's actually seated within the hole. And that makes sure that you have an extra strong joint. There we go. Now we won't be able to go into the hole with these bigger wires because there's the capacitor going through them. For these inputs, I'm going to bump up my temperature to 400 because I know from experience that the ground pad requires a little bit more heat. Okay. Oh yeah. Oh yeah, look at that. Beautiful. And just inspecting that it's not touching the other one. It's next to the other ground pad, so even if they are touching, it's no big deal. So I'm not going to worry about that. Okay, and then a little more solder. Okay. And then this one is where I have to be careful not to touch it. In fact, I might even just place it to the side like that and then hit it with a blob of solder there. Okay, I can't see what that looks like. Just looking at that, I can fit my fingernail in there between the processor unit, and yeah, I don't like that joint. So if you need to do a joint over again, just warm up your soldering iron, apply some solder again, and just decouple that joint. And you know what? I'm going to trim this wire a little bit shorter. And the reason why is I don't want this shorting against the capacitor here, because the ground, you know, the ground isn't touching the capacitor, but just in case. Okay, and let's get a good sizable lump on the tip there. Okay, and try this again. There we go. All right, so that's looking pretty good. Now let's clean it off. So the flux I'm using is no clean. So that means you can leave it on there and it's not going to damage the plastics of the electronics. And it's an insulator, so it's not going to short anything, the residue that's left over. But I'm cleaning it off because I plan to conformal coat the regulator, because especially your DJI regulator, I want to make sure that that is not going to be affected by moisture, because your flying depends on this DJI air unit. Something that I failed to mention earlier was these wires I pre-cut to the exact length that I know. And that way I don't need to fit everything together while everything is soldered. Instead, if I know these wires are the correct length, then I can just solder them and not have to worry about it. And I don't know, maybe I'm not explaining that well, but I've gotten to the habit of pre-cutting my wires to the correct length instead of assembling everything and then choosing the correct length of wire. That makes things a lot less fiddly, so that you're doing all the work outside of the drone, and then you only have to do as much work as you need to while the components are installed into the drone. Okay, what I did off camera is I took a heat gun and I dried off the surfaces to evaporate the isopropyl alcohol, and also just warm it up a little bit so that this silicone conformal coating could adhere to the board even better. The most important components to get with this conformal coating are the processor units with those contacts or those legs that are really close together. Okay, now I'm gonna dry this off with the fan a little bit and then use the heat gun to speed up the drying process. Alright, this mamma jamma has dried off, and now I'm going to put some heat shrink around it. And the reason why I do that is to create a clean surface for double-sided tape to secure to the drone frame, and it also protects it from like mud and debris and things like that. Now this heat shrink is a little bit too small. Notice I'm not able to get it on fully, but the reason why I chose a smaller size is so it can conform better to the shape, because it's in a regular square shape. Heat shrink works best on cylindrical shapes, but this is obviously not cylindrical. So a trick that I learned from Mr. Steele in one of his videos, he pre-stretches the heat shrink using some needle nose pliers. Just work at it. Don't just like stretch on one side. You got to rotate it a little bit so that you don't create stress concentration, and then rip it or tear it. And you can really stretch it quite far before it actually tears, and it will shrink all the way back down to its original size. Okay, let's slip that over and hit it with the heat gun. So that did a nice job of wrapping around all the components to some degree. Here's the moment you've all been waiting for. I got the Big Mama chisel tip. This is the biggest tip for the Hako. And what I did beforehand is conformal coat all the sensitive portions of the electronics in order to protect them from solder bubbles that may happen, or solder balls that may jump out during the soldering process. And with this particular board, they spray on a Loctite 3900 conformal coating, and it's acrylic based. So normally I use this silicone stuff, but I would not do that for this board because silicone, it would not wet properly and it would not be able to wick into the electronics. So instead I used an acrylic based conformal coating so it would fuse with the base layer, because the sprayed on layer that they use is not adequate for weatherproofing the electronics. Okay, so let's heat up the soldering iron. We're gonna just, when applying our tin layer, we can just keep it at like maybe 400. No need to go overkill. So P4 is my preset. Let me just do this thing. Oh yeah. Okay, y'all ready for this? So I'll just do it once without explaining. So I just kind of dragged the solder along as the tip is in front, advancing and heating up the rest of the board. Usually I find that it's the ground side of the board that takes a lot more heat, and that's because there are ground planes within the chip, I believe, so there's just more material to heat up. Okay, so that's looking good. Next I'm going to prepare my peripheries. So this is one of them, an important one, the XT90, and let's see, with this, I'm only putting the temperature at 350 Celsius. So once again, we can still use the T-strippers even though they're only made for a lower gauge wire or a smaller gauge wire. So the trick with this is you can kind of just chomp. The chomping action is key. Chomp, 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 chomp. And then if you want to chomp it in such a way that it will prevent fraying, only chomp in the righty-tighty direction, because I believe that's the direction that most of these wires are twisted in. So chomp, 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 and there we go. So that looks good, and it hasn't frayed too much either. Okay. Next. Yeah. Dribble that on there. Okay. And let's prepare our stuff. Okay, with this you can get a nice big glob of solder on that iron. And a trick for this is you can kind of take some dexterity. You can wrap it around like that. Or if you don't want to do that, if that's a little too advanced, you can just do the side action. So top, side, bottom, other side. Maybe even hit it from the top. All right. Load it up again. And let's do a little bit more, because this 10 gauge wire really soaks it up. And the longer you leave it on there, the more the solder is going to wick along the length of the wire. So the more it's going to travel up the wire, and the less flexible range you're going to get out of it. And so if your temperature is too hot, like if I was running 450, it would wick much quicker, and there would be a longer portion of the wire that would become rigid, which is not what we want. We only want the solder to really be rigid, you know, in this region right here, and then we want the rest to be flexible so that the joints have as much strain relief as possible. Okay, I'm heating up the tip to 450, and I'm going to reapply flux to both the wire and the contacts. Ooh, that's pretty nasty looking. Let's wipe that off. Much better. Okay, so you want a good glob of solder on there just to act as a heat dump. Okay, so we got flux on both sides, so it should flow pretty well. All right. And we're working quickly. We want to work quickly enough that you can actually hold it with your fingers and not get burnt. Okay, so there's the positive. Now the remember, the negative is always a little tougher. It just has more metal, so that one's a little bit more difficult. We might have to linger a little bit more. And you might have to add a little bit more solder to the tip to have a bigger heat reservoir. Okay. That's looking pretty good. And just double checking that my connector is straight. As you can see, it's a little crooked, so that's not to worry. If you need to redo the joint, reapply some flux, get a fresh tip again. You don't need as much solder this time, just enough to heat it up. And let's hit it and twist it. Let it cool down. And that's a lot more straight. And you know what? I'm a perfectionist, so I'm going to actually straighten out this positive. Normally I probably would have gotten it right on the first try, but working behind a camera is a bit difficult. Okay, let's see if that was good. I think that was good. Yeah, that's a lot more straight. Okay, and so this I pre-measured, so I know it's the right length. Now it's time for me to switch tips. This one is a little too big. Now we're going to do a hot swap, and that's a little bit being like a cowboy, but that's how I roll. We're going to hot swap it for the slightly smaller tip. As an aside, I want to show you how effective pre-tinning is, especially when joining to wire-like things. So for like this capacitor, check this out. That's it. Like, it just perfect. Okay, so I got my peripheries set up. I got my 12 volt regulator here, my all-important capacitor, and my 9 volt regulator for the DJI air unit. These are all the things that are going to be attaching to the battery terminals. First, let's start with the capacitor. We got 18 gauge wire, so we're going to do that one first. Like, work biggest to smallest. And what I did off camera is I cleaned up the battery pad terminals with isopropyl alcohol to minimize the buildup of flux residue. And I set my soldering iron to 400 because we don't need as much, and we don't want to desolder the XT90 plug. Okay, everything's ready to go. Let's hit it. There we go. And let's add a little more solder to that tip. And let's do the ground. And it helps to pre-bend the wires. And it's okay to like press on it and then take it off just to inspect as you're going. So notice how I was hitting it, taking it off and looking, hitting it, taking it off and looking. That's okay. It produces solder balls, but luckily I conformal coated my board beforehand. All right, let's clean off. It helps to clean with isopropyl alcohol between every step. And because if you just wait to do it all at the end, the buildup becomes so great that you'll have to use a screwdriver or something to pick off the buildup of residue. And kind of unavoidable are these little tiny charcoal specks or whatever the hell they are. Okay, continuing at 400 degrees Celsius, I'm going to prepare the tip again. Clean that stuff off. Normally I would not put solder on the tip so close to the board, but I'm doing that for camera viewing reasons. Okay, let's do the ground side first. I flipped it around since both of the regulators are on the front part of the drone. And I'm just going to situate them between the capacitor and the XT90 wires. So this part's a little tricky because you can actually desolder your previous solders, which is annoying. So that's why the tappy tap method is good. It's not really tapping, but like the press method. There we go. Okay, one down, one more to go. See, it gets a little annoying with the solid core wire having to reapply that flux to the wire, but it's worth it. And I'm going to put the next regulator pretty much right on top of the other one. And we can use our finger to hold the other one in place since we're on the same side. Oh yeah. See that little solder ball? Gotcha. Okay, next one. A little more. Okay. Put this one off to the right a little bit. Okay. See, I almost desoldered the capacitor there, but that's looking good. Let me clean that off. After cleaning that off, it looks like, I don't know, to me, the joint on the positive side looks a little cold. Because those edges seem a little sharp. It's not like a smooth transition like it is on the negative side. So I'm just going to hit it again and make sure that solder is flowed and fused with everything else. See, it didn't work. That's because I forgot to put on flux. That's why we use flux. Okay, I got more tip on that solder. Okay, cool. That looks a lot better to me, don't you think? Okay, so just to show you how pre-planing really helps, I already fished all my motor wires through the frame and I pre-tinned them. So all I have to do really at this point is plop that guy on there. And I got this TPU chassis mount I designed for XT90s. And there's another half to it. It like clamps around with a stainless steel zip tie. I got my capacitor zip tied to the battery leads. And then my regulators I hold down with double-sided sticky tape and zip ties.
So it's super secure.
All right, I hope these tips in the demonstration give you an idea on how to improve your own soldering process. And I wanted to share this because the more we can make our electronics reliable and have our drones be safe and secure in the air, the more it will benefit us all as an FPV community, especially in the public eye.